Okay guys, so we have another chapter, the third chapter exercises here. So we have 0, 0 here. I'm pretty sure you know this one, so this is the other following video that I posted regarding digital logics and their chapters. This is the third one, is a continue of the second. So this is 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0. This is NOR gate, ABC input, and the 1x output. 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0. So let's draw the output of waveform OR gate. As you can see, don't forget, this is really important, because this is how we do the X here. This is the best way to draw the table, to find the X, really easy here. As we know, whenever we have 1, we have to do it all the way 1. But when we have 0 at that side, of course we have to use 0. For example, like this. I don't know if I can write it. No, I can't. Sorry. If we have 0 right here, in this case, it means that x would be 0. We have 0, 0, 0. And we have 0. But as soon, listen to me, as soon as we have 1 there, we directly write 1. You don't care. As soon as we have 1, we have to write it 1. Let's check it. We have 0 here, so let's write 0. Let's go. We have 1, 1, 1, 1. We have another one here. Then later on, continue of 1. The next one is 0, 0, 0. Let's write 0. And the next one is 1. You see, this is 5 volts. This is on. This is a high voltage. So we have 1, and later we have nothing with 0. This is the waveform. Input the figure blah 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 station is shorted to ground. Therefore, draw the resulting output waveform. This is 0. Oh, don't forget that. This is 0. Let's check it one. 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. C is 1, 1, 1, 0, 0, 0. So it means we have here ones. We have 0, 1, 0, 0, 1. The 0 here. We have the perfect 0 here. And here we have the perfect 0. But here we have 1, 1, 1, 1, 1. And here have 0, perfect 0 here. Here have 1. And we have 0 here. Yes, this is done it as I said it. This is 1 to the end. 1, 1, 1, 0. Yes, perfect. This is a perfect 0, perfect 1, perfect 0. Don't forget it. Just try to be careful about the table that you write, because it's really important for you in the near future to check that out. The inputs of BN law and CR law during the intervals T1 minus T2, T3 minus T4, blah blah blah. So the output of X is low during the other time intervals. One more input are high, so the other output is X is high too. Change the OR gate and to the NAND gate. Okay, perfect. As we know, the AND gate formula is A times B times C. You have to draw the output. Okay, perfect. Okay, we know this one. And let's do it. This is 0, 1, 0, 1, 0, 1, 0. 0, 1, 1, 1, 1, so it means here we have perfect ones, but here we have 0, here 1, here 1, we have zeros here, then we have 1 here, then we have to a perfect 0 here, later on we have 1, 0, 1, 1, 1 to the end, you have 1 here. In the last one, you have 0 on the last one. Let's check it. Yes, this is the waveform of it. This is the following inputs of waveforms of AND gates. Yes. Okay, but what's the real question of B? Draw the output to waveform. The A input is permission to the ground. Yeah. The output of waveform and gate output A is due to low for the input waveforms B and C are shown in the figure. Yes, yes, and X will be like this because the output waveform. Okay. When now the inputs of the AND gate is held. which is low. In the output waveform, the AND gate will always be low. And yes, because this is the AND gate, guys. Okay, this is the AND gate. 1 A times B times C. When 1 is off, means the X is usually off because A is off. Perfect. You really understand that, I guess. So the X would be 0 1 0 0 1 0 0 0 1 0 0 1 0 0. Yes, of course. We have to write a Boolean expression output text and figure. And we repeat it. A naught is the R. B end, okay, B naught, A prime, B prime. All of them are A and B now because of this gate here, then A times B. Yeah, it is A plus B times B times C. Yes, this is double component, but we have to remove it because the negative of negative gives us a positive of that. So A plus B times C. The following truth table. Okay, blah blah blah. You have the following secret diagram here. So this the NOT gate here is in the NOT A, or the A prime of is down to the AND gate here with 3 AND gate and 1 OR. So we'll put it all together to do the sum of products. The circuit in figure 2 is redrawn for analysis. Okay, no problem. You have to apply the input of waveforms and draw the output. Repeat. Okay, NOR gate. Okay, this is perfect. NOR gate output will be high when all inputs are low. All 3 inputs are low during the interval T0.62. The output waveform of the NOR gate for input C will to high. Okay, create a circuit and logical. Okay, A plus B times C in this case. A plus B times C all inverted. Oh my god. Then we have put T plus here. Letter E times all of this. Okay, this is a truth table of it. Oh, thank god we have done this one. We're safe. So I had to remove it. Yep. For each of the following expression, construct the corresponding logic circuit using AND and OR gate inverters. This is A plus B with the OR gate times the AND gate. A inverter plus B inverter. This is an OR gate, but these two are connected with an AND gate. As you can see, perfect. Yeah, I knew it. Okay, perfect. Simplify the following expressions with theorem. Yes, plus simplified. You have ABC plus the expression of fill out. Okay, let's do it. Let's check it. A prime is B, C prime is C prime. So we have to choose B and C prime because we have all of them. So it is A prime plus A plus D. And we have to use it now. We do it directly here, okay? 1 plus D. Yes, I knew it. Yes, this is easy. A plus D. Yes, 1 plus D gives us directly C prime. You simplify the following steps with De Morgan theorem. This is more complicated, so don't worry. Okay, plus B plus C. Oh, so I don't think we have to do it. So see like that, yes. Why why is this like that? Yes. Like this is really the following game expression, the same as that. So we have factorize. I have this with factorize A. Yes, I get it. No problem about that one. I don't know why it's like that. So sorry. Therefore, okay, but why though? Yes. This is the moment theorem because plus give us multiplication here, and the plus here give us multiplication. That's sign. And multiplication give us plus. So the following expression. Let's check it. Okay, this is done. Okay, perfect. I understand it. Yes, it did directly. I thought this is like that. Okay, no problem. I tried to debug them. It's really easy. This is the bit A times B. This B inverted. This will not be inverted. Perfect. Okay, there's an expression. This would be the same but not inverted. Or this could, yes. Following expression would be like A plus C, A times C times D. Okay, this is really cool, huh? This will be A prime. This is B plus C prime. And D. Okay, let's do it. But I'm pretty sure we could do it like BC and A plus here. Okay. Yes, they are correct, but only the signs here. Be careful with the signs too, because I made a mistake only with signs. Plus A prime plus B plus C prime plus D prime. And the following given expression. The following is given expression. Okay, perfect. This is really cool. This is really cool. One, I don't know if it's 3, 2, or 4 because this 3 means that it is inverted A. B is also inverted, and my C is not inverted. Plus B should be A plus B plus C, and the times D. No, it's correct. Sorry. Okay, I'm correct with the prime signs, but only with the addition. There is a problem. So. Then we are divided here. Okay, times C plus D. But I'm pretty sure we can use like the plus sign, but I don't know yet. So sorry guys, have a great time and okay, goodbye.